This is what you see once you have logged into Tinkercad. And to give you a little background, Tinkercad was an independent program that was really developed to have the most basic web interface, and it uses solid objects that you add and subtract in order to get your final shape, which means that it's really good for 3D printing. Other programs might use planes, and then you have to be worried about if your object is closed or not. In Tinkercad, your object is always closed. So it's very simple. You come to here, it saves your designs online. And this was purchased by Autodesk, which sells Fusion 360 and lots of other software. They revived it, thankfully, actually, from being a startup that had collapsed when they bought it, and have kept it going primarily as an educational tool. So it's for them to reduce the barrier to entry so that students and people who haven't used CAD before can get started. And it's great in that it does a lot of things, but pretty quickly, if you're getting sophisticated, you're going to find that you need more complex software. You'll also notice that there are modes in here that are very specifically aimed at keeping the interest of students. Like there's a Lego mode and a Minecraft mode, which we're not going to get into, but you'll notice them as you're exploring. So to start off, you'll see this blue plane, and you can click on your second mouse button in order to click and drag and move around in space within this plane. Another option is to quickly jump to points of orientation. So you can see if you click on this box here, you can get to the front, or you can click on these directional areas to get to directly on top, on back, left, right, so on. So we're gonna continue to work just as in this regular self-directed view. So the first thing I'm going to do is I'm going to pull a square into the scene. And that's as simple as clicking on the box and dragging it out here. Now, we have some settings that we can change on the box, including turning it into a negative shape, which I'll get into in a minute. We can change its color and so on. For 3D printing, color doesn't matter, although it can be useful as you're working on your design and just keeping things visible. Now I can change my length, round the corners, width, and various other options. I can also do this by going and grabbing the grabbers. So there's two types of grabbers. There are white grabbers, and there are these little black node grabbers. The node grabbers will just expand one side, and you can see it'll give you the dimension along that side. You can do this on any of this. So this is nice to have a nice controlled expansion in one area. If you grab the ones with the white center, you'll see that it's more dynamic. So this is for roughing something out more quickly, but it's more difficult, obviously, to keep one dimension continuous as you're expanding and working on both dimensions. In addition to changing the dimensions of the square, you also have this option, which is a little up arrow, and this allows you to loft or lift your item. You can see I can shrink that. You can see as you loft, you get the dimension from the work plane displayed. Now, if I wanted to have this be 20, I could actually type 20, and it will jump it up there. Same with the dimensions of the box. I can simply have that dimension pop up, and now if I want that to be 60, it's now 60. Or if I want it to be 30, it is 30. Why don't we have you guys pull a box into your scene and start changing the dimensions make a rectangle, much like I'm making it, and loft it up. And just let me know as you've been able to do that and any sort of challenges that you have in making that happen.
JR, those top two, those are like negative space cylinders and boxes. The
Yes.
ones with the...
Yeah, so exactly. So once you guys have had a chance to manipulate a shape, I'll do those next. I'll show you how to add and subtract shapes.
Are you manipulating it?
No, I'll run out of horsepower, so I'm just watching.
Cool. And I see Julia's trying to import and use SVG export function to Inkscape. Cool. We'll get into that too. All right. Has anybody, let me know if you had trouble pulling it in there and manipulating, and if you have any questions. But otherwise, I'm going to continue moving on. And so the next thing I'll do is I will show you how to subtract a space. So let's say that we want to take the corner off of this. What I can do, we wanted a cylinder to intersect so that for some reason this shape's going to sit on something else. Now I just dragged out this cylinder negative space, and you can see I've aligned where I want it to be. Now, in order to commit that, what I need to do is I need to highlight it. So I've just clicked and dragged, so it's highlighting both. Another option is to hold down the Shift key and to click each of these, which will allow you to select both. And once both are selected, you come up to this option that says Group. And once you have grouped, the negative and the positive space have now been combined to create a shape with that cavity missing. Does this make sense to folks?
Yeah.
Cool. Now, I just eyeballed where it went on the corner. One of the things that gets more useful is often you'll want to take, say, a shape out of, two smaller holes out of the side of something or through it. So I'm going to say 5 by 5, and I'm going to extend this up, and I'm going to approximate where it goes, and then I'm going to say copy and paste. Now, it might be, oops, wrong object. It might be hard to eyeball these into alignment, right? So now you're messing with it quite a bit. But if I select both of these, what I can do is I can come up and go to this Align tool. And the Align tool will bring up these little circles. You can see them here. And these are alignment over lots of different ways. And where I want to align them is I want to align them so that they are this way. So if I click here, you can see there's a little orange preview, little circles show up. That shows me where the alignment's going to go once I click those. So that's what I want. I want them side by side. Boom. I've now aligned these two. Now the problem is they're not centered on the blocks. So in order to center them, I can select both of them. Now I'm going to group them together. So now they're going to act as one shape. I have these two grouped, and now I take that group. I also select the square, and now I can do an alignment again. So I can align it, and where do I want to align it? I want to align it to this midpoint. So it just, if you see, it just nudged those over there. And even if these had been severely off, I could have done that. I could have selected one, then the other, then gone to alignment, and then so this is find the midpoint, and it's going to move the other one over as well, but it moves them both together, and now you have these items. Now I didn't align it to the center. Had I wanted to align it to the midpoint through the box, I could have done that with this one. It's showing me where those are going to show up. And now I have two holes, or future holes, in my box. I go there, I group it, and there are my two holes. You can also take an existing object and turn it into a negative space. So let's say I wanted a circle. I can bring it up, bring it over. I can distort it. Then I'm going to center it. So I'm going to click this, and now my box. And I'm going to say I want it centered this way, and I want it centered this way. And so now it's right in the center. I can click that shape. And up here, I now have called it a hole. And when I group all of this again, so now you have groups within groups. And now I have a little pocket with my holes. We'll give you guys a moment to catch up and create your own negative space inside of the cube and do alignment. You can do it whichever way you like. But go ahead and try that now and let me know where you get stuck. I'll show you a couple other things. Yep.
Question really quick before.
Yeah.
So if I set my two screw holes basically, and I've got them aligned and they're off, they're not in my red box, and I want to move them in, I'm having trouble. Is it just select to click both, or control? Because I can't drag them now once I get them both selected.
Oh, interesting. So
I keep just loading one of them
once
and they get tilted.
So if you select something and select something else, you should be able to move the two of them as a group, not even as a group, as just two selections. So holding down Shift can do that, or highlighting and moving. And then if you want to have them more permanently, semi-permanently connected, you group with that little group item. So they should move together. Might just take a little practice.
Yeah, I think I might just be grabbing in the wrong places because it keeps wanting to draw a little red box.
So try holding down Shift and just clicking. Not sometimes the drag is you could select other objects by mistake and so on. So it's good to get used to the Shift. When you're aligning things, there's a couple of tools that you should be aware of as well. So you can move objects bit by bit by using the control keys. So I'm just using the cursor keys, the arrow keys on my keyboard, and I'm moving those around. And then if I hit control, the up and down arrows move to moving up and down. So this I find sometimes is more accurate than moving around with the mouse. The other is that this is in perspective, which looks very natural to us because that's how we see the world. But we can move into orthographic mode. And this looks a little strange, but it takes the perspective out of it. And so it's really good for when you are aligning items and try and just get a different perspective on it when you're exactly right, exactly left, exactly the bottom. Where if we were to look at these in perspective, they would be more difficult to say where things were aligned. There are specialty objects such as text that once you bring it in, you can modify it and change the font, and so on. And this, of course, can also be turned into a hole, so it can be made into a negative space. As
That's cool.
you
You can just save part numbers or whatever.
yeah, exactly. You can just subtract out and make a little divot. So there's a whole bunch of shapes in here. Many of them have some sort of modifier, which makes them more useful. So yeah, for example, this ring, you can change the form factor of the ring. So if we wanted a very thick gasket type thing, you have these modifiers that are allowing me to squish and create a shape. That shape can then be added and subtracted. So you might, if you only needed half of it, you might take a square, a box, and slice it that way to get almost a wing type shape. This, you know, donut with the like the teardrop almost. If you go into shape generators, you can see that there are lots and lots of these more specialty ones. A lot of these are created by the community, and they're used for springs and all sorts of other, you know, funny shapes and propellers. And I was just looking at featured. You can also, if you go through them, there's a whole lot. If you're creating walls or birdhouses or whatever, when you find one you like, you can star it, and then those starred ones will be available within your own favorites. So that makes it easier to figure things out. Also, if you are trying to do very more accurate work, there's this ruler, so that you can pull the ruler onto this plane here, and it will keep available more of the dimensions. And so you're seeing the associated dimensions with this ruler, and you can start changing them. Now, one issue with Tinkercad is that once you have grouped something, you're modifying that whole object. So say if I change this to 60, well, I've actually now just distorted my holes, my little holes through it. So if I wanted to keep those holes perfectly round, I would actually have to I'd have to ungroup this, right? Get back to the hole so they're separate objects, change the dimension of that shape, and then regroup it. Where with a more sophisticated CAD program, you can address those items within the object separately without having to go through the whole process of ungrouping and regrouping. So that gives you some concept there. I'm just going to check my list of things that we said we would do. And then we can get into the exporting part of it. So we've done dimension sizing, exporting. All right, so we want to do importing of an STL. That's as simple as, and this is great for things from Thingiverse or other places online. You go to the import function. I think I have a little robot on my
oh, this would be great for like, oh, like this part is perfect except for it has a rectangular magnet and I can only find round ones.
Yep. So I'm importing, this is actually a mold my brother sent me. So it might be a little unwieldy, but it'll be something we can check out. So here's the object, and there it is. Something I actually haven't covered is how to rotate. So for whatever reason, his object is skewed. To rotate, there's these little two arrows that you can use. And so you can see I'm rotating it in space that way. And that is a rotation that is in steps. So you can see these little lines here. it's jumping to those, and that makes it easier to make sure that you're exactly aligning it to the bottom plane. And so, but this took me a little while to figure out. If you move your mouse to the outside of that circle, it now is a free rotation. So if you don't realize that and you're trying to do the rotation, you're like, why is it jumping and sometimes it's smooth? Well, it's based on where in the circle you are. So this allows you any degree, and this gives you only the predefined degrees that are on that circle. So you can see here's the mold. And so if I wanted to add another item, subtract a little registration hole, I could do that. There it is. And then I select the mold, select both of those, group them. And now I've cut a hole out of that existing part. So I'm going to get rid of this because we don't need it. But just to know that you can add and subtract to existing STLs, which comes in really useful when I use it all the time when I just want to do something really quick, add a geometry to something, and I don't need to boot up a whole other piece of software. I'm using my Chromebook. I could just jump into Tinkercad and make that change. Just to keep it simple here. Group that, and I'm going to place it back on the ground using that little cone. Okay. All right, so one other thing that's useful, you can see that my camera is not aligned right now to where my box is. So I can always select the box, and then I can go to the home view, or I can go to the selection view. I can also, in my case, I can depress the wheel on the mouse, and that allows me to move side to side manually. But often you'll find that just clicking on this little go down to the object that you're viewing, that button there, will be useful in getting to the object that you want. Now let's say we're going to 3D print this. That would be to export it. So that's simply just going to this export button. You can export everything on the whole page or just that shape. And then we typically work with STL. And there we go. We now have an STL called Spectacular Go-Go. Tinkercad automatically names everything, just a funny random generated name. So we could have renamed it to example class, and then it would export to that name. You can also collaborate or invite people to design with you. So this will generate a link, and that link other people can access, and then they can make a copy of your design.
Quick question.
Yeah.
So when you export to, I think you said the SPL file.
STL, yep.
That creates a file on your desktop, or does it create a file in the cloud?
It downloads to your desktop. And STL is a standard file that you would upload into any slicer that's used for 3D printing.
And that's the file that you would take to MakeHaven and send it through the Octopi system into one of the printers. Is that correct?
Exactly. So that's what would slice up, and you would be able to use another piece of software. And there's various other slicers that prepare it for 3D printing. But the STL is your basic shape. And so that's like a fundamental thing to be able to get. Just another option, not that, I like the people doing it themselves, but there are some cloud services out there. You can also send them to like Shapeways, other services that will print and then mail it to you. For laser cutting, so I'm not very experienced in laser cutting, but Julia asks if we'd look at this. So my understanding is what it will do is it will take the profile of what is touching the ground. So I think for laser cutting, I would actually use another piece of software that I can tell you about. The slicer for Fusion 360. It's a separate plugin that you can use independently, and it will take an STL from here and slice it up to make it appropriate for laser cutting. And so maybe at the end of this, I can give you a little. I'd have to jump onto a different computer, but I can at least pull up a video of it. So let's export, and for SVG, which is a 2-dimensional file, and so we're gonna show this folder, and I'm gonna open with Inkscape, and I'll have to reshare my screen here in order to get to that once it opens.
So Julia had a question about it closing holes. Too.
Closing holes. Okay. All right. So I will share. I got limited success with my export to Inkscape. So I'm going to go ahead and I'm going to share a window. I'm going to share.
While you're doing that, can I ask you a question?
Sure.
All right. So that object had 6 sides to it. And I notice a lot of times at MakeHaven, somebody prints out a box, all 6 sides. They cut out a box on a piece of wood in the laser cutter, and all 6 sides come out with an interleave dovetail kind of thing that they lock in together.
Yeah.
Then it forms, you put all of the side panels together and you get this shape, I guess.
Yeah, so that's something different. So you probably would design that in Tinkercad. There's actually several box generators that are out there. And if you go to the project page on MakeHaven, there is a how to make a laser cut box is one of the projects. And it will link you to the generator that's there. And Julia says that MakerBox is one that's popular. So just you're probably seeing my export of the SVG in Inkscape. And what I got, is I just have the outline of the bottom where the 3-dimensional object intersects the plane on the bottom. And I don't think it added, there's no layers with other data. So I'm not extremely impressed with the laser cut ability of what you can design in Tinkercad. What is probably more useful is I'll pull up in a different window. Let me first Fusion 360 slicer is what I'm looking up. And I will share that. I think that's what I'm sharing. Oh. So Fusion 360 Slicer will take your STL. So you bring in, it's a standalone program, it's free. You take your STL, and then it will give you various parameters. Let's see if I can pull it up here. Yeah. And it allows you to say what are the various shapes you're using, and then is your construction method. You can change all the variables about how far apart things are, and then it will break it into planes, which you can see here as laser cutterable surfaces. This is used in like prop making and so on to get just like a basic shape even, which you can then add additional surface and paper mache and other things around. And so a workflow would be to design something in Tinkercad, bring it over to the Fusion 360 slicer, and then take it to a laser cutter. If you were to go 3D printing, you would go to your 3D printer slicer.
Quick question.
Yeah.
Did I understand you right, that playing around here in Tinkercad what you learn in this with this program would be an easy transfer of skills into AutoCAD. Is that correct?
I think that it is conceptually a first step in understanding how to manipulate and work with this sort of modeling software. It will be another thing that has to be intentional learning to be able to use other software. I thought AutoCAD was two-dimensional primarily, though I may not be up to date. So typically somebody would go to Fusion 360 or SolidWorks, or there's an online one called Onshape. So there's several CAD programs available that would be natural follow-ups to getting good at Tinkercad. But if you just, you can learn Tinkercad in an hour and be like pretty versant in it.
Not so in AutoCAD.
Yeah, those other programs are going to take you some time, but I think that Tinkercad is a good step-off point, and you will find, especially if you're doing engineering type modeling, you're going to find that you need to jump to the more sophisticated version later on.
What company is responsible for making Tinkercad? What was the company's name behind this program? I mean,
this is Autodesk, and I see Julia is asking if you need the paid Fusion 360 subscription. My understanding is you don't. So I just did the Fusion 360 as the individual entrepreneur, and then the Slicer program is actually a totally separate program that sits on its own, and I think you can use it without even registering. You just search for Fusion 360 Slicer, and it's on the Autodesk page, and you download it and use it separately.
I probably should ask the question a little bit different. Does Autodesk have a more advanced version of this Tinkercad that this makes a reasonable step into the more advanced version of it?
Yeah, so Fusion 360 is their more advanced version of Tinkercad. So Fusion 360 is aimed at the professional engineering world. It has all sorts of additional features, like being able to test stresses, being able to directly work with machining, having all of the abilities to step backwards through your design. So when you're working in Fusion, you are dimensioning everything. And if you want to go and change the size of the hole that you did at the very beginning, you can go back and look at the version that you did at the very beginning, make changes, and those will propagate forward to your final design. So you're working with a much more sophisticated system, and that for non-commercial use, Fusion 360 is free to use or accessible. Though once you start making money on it, they have a requirement that you buy a monthly subscription to it. So there is, obviously the costs associated with that. But there's great resources for learning it online as well.
Good, thank you.
Yeah, other questions. So we, so let's get the box question. So to closing, Tinkercad automatically closes holes. It should, what it is it's working with primitive shapes. So if you're working in Blender, at least when I was playing with Blender, I don't know if they've improved it. It was possible, because you're dealing with all the little polygons. It was possible to leave a shape unclosed, and then your slicer program would have trouble knowing what was the inside and the outside of that shape or that object. Software's gotten a lot better at that in general, but Tinkercad was always very good in that you're using a box. It's already a box. You're not drawing the sides of the box to assemble it. And so that therefore, pretty much always when you went to go export it to 3D printing, you would get what you expected. And so that's really what I was commenting on there. Yeah, so there's other programs where you can work in 3D. So yesterday we were just playing around with Modo, and Blender is one that's fantastic, and you should learn if you're doing organic type stuff, where Tinkercad has a lower barrier to entry than Blender, and is less powerful. Blender would be if you were going the route of wanting to do organic shapes. It's out of film and animation is how that developed. And so you can make beautiful organic things. You can actually manipulate stuff, sculpting it like clay. But if you wanted to be in a more engineering mindset, you would go to Fusion 360 or perhaps SolidWorks. MakeHaven members actually have access to a free version of the educational version of SolidWorks, which is a pretty amazing benefit. And that is on the, if you go to the member resources and into the discounts and bonuses or something it's called, or benefits and discounts link on that page, it'll give you the instructions on how to access and download your free SolidWorks copy. Other questions?
I just wanted to throw out really quickly, with Blender, I mean, we have quite a few artists in space. There's been a lot of upgrades over the past year and a half. They've got a new grease pencil tool, and a lot of things really for visual artists who like working in two-dimensional or offsets like 2.5. But there's just a lot of artistic tools that's something that someone wants to get into, just to keep in mind.
Absolutely. So we did an informal thing yesterday during Colin's facilitator hours, and that resulted in us setting up there's going to be a session where he shows you how to make a cup in Fusion 360. So that would be a really good next step to get a sense of that engineering software and how that works. And then we haven't put it on the calendar yet, but we're going to do something in Blender where maybe we make the same thing, a stylized cup, just so that you can see what the difference is between the software. And yeah, and Blender is amazingly impressive. And I haven't played with it recently, but I've been told the interface has been drastically improved. And because it used to be very, very difficult to learn, but it's gotten easier. It's not Tinkercad level, but free, open source, and very powerful.
Sorry to keep stepping on it, and definitely don't want to monopolize, but on the cup thing, whether it's a cup or a stein, I think from a training standpoint, it would actually kind of make sense to have like a standardized, if we're going to work in a three-dimensional space and do like a introduction for a lot of people for new software, or like the first two rungs at it, to maybe have a standardized shape that we're all going after. That way we kind of know comparison wise what it took to get to one here versus over there.
Sure. Yeah, I could make a cup for you in Tinkercad if that would be illustrative or illustrate.
I'm probably too caffeinated right now, but I appreciate it.
Yeah, Shannon,
because it's gonna make like a coffee mug. You know, you make a cylinder with a blind cylinder inside of it that goes most of the way down, and then the half ring, like you showed earlier, like that would be
exactly
easy.
Yeah. So why don't, if you're in, I'm just going to go ahead and I'll make one, because it should be really quick to do, and it does use a lot of the tools. So just a very simple one would be the cylinder, and this is the grid is in millimeters right now. We could move to inches, so you can change it, And you can also, this is something I should have mentioned, is you can change the step. So right now when I'm dragging, it's jumping in millimeter intervals. If I want to jump in 0.5 millimeter intervals, I can change that setting, and that gives me more granularity. But it is useful to work in a larger step. So I don't know, how many millimeters is a coffee mug? Somebody know?
Probably like
We'll go to inches since we're in.
no, 100 would be 4 inches.
Yeah. So well, I just changed the grid over to inches, so that we have that. So I'm going to say 4 inches by
3.5 inches for a big cup diameter.
Okay. So well, okay. So we'll go 3.5, and yeah, 3.5. All right. And now I'm just going to eyeball height. Oh, we don't need to float. We want to grab the top of that. I'm going to say something like that. It's kind of a coffee mug-ish. What I'm going to do is I'm going to duplicate.
5 inches on this one.
Duplicate this. And I'm going to, just to make it simple, I'll pull the ruler in. There we go. And so now my dimensions are, and I will orient to this one. And I will say 3.25. 3.25. It's going to have somewhat of a thin wall. Maybe even make it thinner. I'm just going to go 3. We'll do it, and we'll see what happens. There we go. Now I'm going to loft it. So we have a bottom of our cup. And now all I should have to do is select these two. And I'll use the alignment. So I'll align this way. Those are aligned. And then I'll align to the center. So now we have that negative in the middle of the cup. Highlight that. So we have the cavity of the cup. And now I want to, I'll use the ring just so I can get a little fancier with how the shape is. And I'm going to bring it up here. I'm going to rotate it. Then I'm going to use the, well, why don't we use alignment tool? So I'll select this one, I'll select this one, and I want to align it on this plane so it's in the middle. And now I can start just get rid of this. All these dimensions are getting in the way, so I'm going to turn them off. And because I just need to eyeball this. Is this? That's width. I want to go up and down. This width. Where's my? Well, I'll just grab this one because it's easy, and then I'll move it down. And I'll move it in. And I will. Okay. So I kind of like a little bit of a. All right, so we have that. So right now I have a ring in the middle of my coffee cup, but since I already have the hole, what I can do is I can ungroup these, and I will put these two together. So these are grouped. And now when I cut the hole, it'll cut the hole from both, right? So it matters like how you group. And so now I have a mug with the, admittedly skinny handle, but that's my mug. Make sense?
Nicely done.
Pretty simple. Though it gets the other software has more tools for like giving rounded corners and those sorts of things. I don't think, even if we went back to this primitive shape, it does allow a little bevel. Oh, look at that. Okay, so we can do bevel and we can add some sides to it to make it smoother. Put it back into grouped. All right. Oh, that's not bad. That's my best coffee cup. A little roundedness to it. Cool. Were there any other questions? Because I think we're coming up on our hour and we've covered what we aimed to cover. Yeah, well, thank you. Julia says, very nice mug in the comments. All right, well, as long
that was helpful.
yeah, and I mean, the mug is actually a pretty good, simple shape to show the combination of things. Well, so good luck to everyone with your adventures in Tinkercad. There are some great tutorials, because it is a platform that's really been oriented for teaching and learning. There's a whole learning section of Tinkercad that will walk you through various exercises and help you to become more proficient at building things that can be 3D printed or brought out and sliced up and laser cut. So good luck with your making, and thank you for participating.
I'm going to use it to do my microbit chassis.
Great.
We'll see how long it takes me to get that done. It
Yeah.
looks like fun.
Absolutely. Well, thanks everyone for playing along.
Thanks so much for hosting, JR. It's great to see everybody.
Great.
Yeah, take care, y'all.